And good morning, everyone. We will be getting started momentarily with track 2 of Hack the Capital. I'll be emceeing this track all day. I'm Liz Wharton. I'm Chief of Staff with Scythe as well as over at ICS Village. And a couple of housekeeping items before we get Ray up and running. At any time during the day, if you want to check the schedule, go to the icsvillage.com website. You'll follow the links to Hack the Capital, and we have the schedule posted. We'll take a break on this track at lunchtime to catch our keynotes on track 1. And again, towards the end of the day, we will jump back over to track 1 and catch the closing keynotes. And the way we're going to set up the talks today is the speakers, if they have elected to set aside time for questions, we will do so at the end. So pop your questions over into the questions box on GoToWebinar. And with that, it is my pleasure to welcome Rei Henigman. Ray is a dominant member at Clarity's research team, leading OT protocol analysis, reverse engineering, and blind protocol reconstruction. Ray has over 5 years of experience in researching networks and performing protocol analysis in domains such as ICS, IT networks, and others. Prior to joining Clarity, Ray served as an elite cyber unit in the IDF Intelligence Corps, where he was working as a cyber researcher in various operations. Ray, did I get everything covered in there?
Yeah, that's okay. Can you hear me?
Yeah, welcome.
Okay, great.
And
yeah, you got everything right.
Excellent. Well, I'm going to turn it over to you and let you share with us the journey of IC project files, visibility, and forensics to exploitation. Take it away.
Okay, cool. So welcome to this talk and the journey of ICS project files. As you just said, we're going to be talking about ICS project files, and we'll soon get to the agenda. But first, I'll introduce myself. My name is Ray, and I'm working as a security researcher in Clarity. Clarity, for those of you that doesn't know, is a ICS cybersecurity company. We protect OT networks, and this protection is based on understanding the protocols and the assets in the network. And in our daily job in the research team, what we usually do is we take different PLCs and we try to research and understand how they work, so we can understand what a proper PLC behavior should look like and how we can detect non-standard and dangerous activity in the network. So here you can see this is our lab. Actually, we like to call it the Clarity playground, because most of our day is just sitting there and trying to play with the PLCs and understand how they work, how their softwares work, maybe understand their protocols and see what we can do with them. And using the understanding that we get from researching them, from understanding how they work, we try and find vulnerabilities in them. And so if we do find vulnerabilities, we practice responsible disclosure by informing the affected company and global CERT organizations. But yeah, let's get to the agenda anyway. So the agenda for today will consist of 3 parts. The good, what are project files and what can we learn from project files? We'll go through different types of files and understand how they are built in the byte level. And the bad, we'll try and understand how those files, how big of a risk are those files for your site. I'll try to convince you that we're really vulnerable to attacks through project files and that they can, in fact, infect your engineer's computer. So yeah, that's the second part is finding those vulnerabilities, and the third part is I'll try to show you that they are indeed not just theoretical, but can actually be used by an attacker. So this flow is actually very similar to what our research team's work look like, because we are starting by trying to understand how the project files work. So what information we can extract from them, so we can help our customers with mapping their networks. And as we look into the project files, as we'll do in a moment, we'll start to notice some bad implementation, risky implementations that can lead to vulnerabilities. So let's get started. First of all, we need to define what ICS project files are, because I'm just throwing the name, but I didn't even say anything. ICS engineering softwares, as you probably know, are programs being used on engineering stations to configure PLCs, to configure the logic and to manage the different assets. So when an engineer finishes working on configuring the logic and the assets in his network, he'll want to save his work so he can come back later and work on it. So the offline working copy of the work that the engineer saves is what we call a project file. Okay, that's just the work that he did, is saving it into a local copy, and this is the project file. And they're very useful for the engineers to keep on working after the system is down. If they can turn off this engineering software and then load the project. So I'll just give a few examples of different engineering softwares. You probably know some of them. This is Rockwell's RS Logic 5000. There's a few more. So we'll go through some of them in the following slides. And let's start to try to understand what information can be found in the project files. So first of all, those are images from the engineering software. As you can see on the left, you can see the different stations in the network and the protocols they're using. Here you can see a S7 station that's a server and that's a client, and they're speaking in the Profibus protocol. So if we can learn from the engineering software, if we can configure in the engineering software the network layout, that means that when saving the work, we'll find the network layouts inside the project files. Also, if we look in a specific asset, we'll find a lot of information in the engineering software. For example, here you can see the different slots of the asset, the models of the PLC, the firmwares, maybe addresses and names. So this information that we see in the software will also be stored in the project file when the work is saved. The same goes for the logic, all the code that the engineer is coding to download to the PLC. For example, those are block diagrams and those are ladder diagrams. Doesn't matter which kind of code, whatever code the engineer codes that will be downloaded to the PLC will also be saved in the project files. And so hopefully that shows you that these project files are useful. They are useful to our research team because they can teach you a lot about the layout of the network and the different PLCs in it and the protocols that the PLCs are using, their addresses, model versions, and also their logic. So you can learn a lot just by understanding the project file about the network. And they're also very easy to collect because project files contains all of the information, the interesting information about the network in a single place. And if, for example, you're trying to think what's an alternative to try and get all this information from a different source, you'll maybe want to try and capture the communication in the network and try and understand all of the network layout and the assets configuration through the network communication. But that will require a lot of work because you'll need to configure a span port and you'll need to wait for the interesting traffic. And it's just not that easy and not that short of a work. So if you're going to use project files, all you'll need to do is just ask your engineer, can you send me the project file, and write a script that extracts the data from it, because all the interesting data is in the project file anyway. And once you have the script, it's pretty fast to run it because the script is ready. You just need to ask the project file from the engineer, and it's super fast to get all the information. So far we only talked about what are the purpose of ICS project files, but how we need to speak about how it is saved, like how is the data looks like, what's the format of the files. So they can be found in various formats, and the most basic example is a text file or an Excel file. It's a file that can be loaded to an Excel. It's an actual project file from engineering software, and here you can see it's very easy to read. It's easy to understand what's the addresses of the PLCs, what's the models, what's the boot version. So if you'd want to study your network, it would be pretty easy to just load this file into Excel and read it. Another example would be that purely textual file Also, you can find the firmware type and the IP address, the MAC address. It's pretty easy to find them just by looking and reading the files. So those are very fun to work with. Also XMLs, they're not entirely textual, but still it's pretty easy to read, and it's also very easy to write a script that parses it. But projects files are not always so easy to read. If they were, I probably won't have a job, because that's what my job is based on. And that's an example of an RSP file generated by Rockwell's RS Logic 5 software. So it's kind of gibberishy. On the left side, you can see the X representative of the binary data, and on the right, you can see the textual representation. I'll give you a second to look. And you can probably say by now that this is not English and this is not text. If we add a text file loaded here, we'll see that the textual representation is readable, but that's not readable. So in that case, the interesting information is stored in somewhere in this binary format, and we need to understand how to get it out of it if you want to study about the network through the project files. So here's another example of a red line file. I think that's generated by the Crimson software, yeah? And if you look on the right, you'll see that while the file is not textual, there are some strings in it. So if you know Crimson, you know that it works with a model name, with an HMI model named G306, so you can spot it right here. And you can maybe see this major, maybe it's a part of an OS, operating system specification, maybe those numbers mean something. So we can see some data here, but we can't really understand how can we extract this data. So when our research team encounter a binary file like this one, our research team will try to reverse engineer the file, maybe black box it, so we could try and understand how to decode it. And once we're done, like in this example, this file was actually compressed by their own proprietary compression that they built, Redline built. And we were able to extract the interesting information to a textual readable format. And here you can see there's the model that we extracted from here. And there's also an IP address, which we can't really see it here, but somewhere when you understand how to read this file, you'll find the information data. We also verified that it's indeed an HMI. We even found that the engineering software that created this file was Redline Crimson free. So those project files contain lots of interesting data, even if they don't look that way, like in the text file case. And sometimes the project file is not really a file. The data is not stored in a single file. This is an example of the Siemens Step 7 project file. It's actually a zip file, but after you unarchive it, when you extract the data, you get a folder. And this folder has a lot of subfolders and different files in it. And now if you want to start and try and understand, get the interesting information about the network from those files, you'll not only need to understand how the files work, you also need to understand where is the interesting information, because in that case, it was hiding in the SDB 0001 folder, but you wouldn't guess that just by looking at the name. So you'll need to try and look through the files. Now, in that case, there weren't so many files, but as an example, in a Mitsubishi project that we worked on, there was 7,000 files in the project. So we had to search through 7,000 files to find the interesting information. So it's not always that easy to understand how this file works. And sometimes it's not compressed with an zip file. Maybe it compressed with a KEB file, with a KEB format. That's an old Microsoft format, and it's not widely used. So it might be pretty hard to find a Python script that can extract data from it. But in general, most project directories are compressed to zip files. That's just the most common use case. And so we want to ask ourselves, what does the most common ICS project file look like? So as we said, it's usually a zip file containing a lot of files in it. And the files inside can come in various different types. For example, the most common ones are OLE files, which are also used in office products. They're great for storing lots of the different data types. And another common type is the databases. A lot of types of databases, maybe SQLite, MS SQL, or Access. It makes sense that people are using databases because they're great for storing lots of data. And actually, the Access, we recently encountered a project file with an Access database, and we couldn't even find a Python script that can parse it. So we had to develop our library on our own. We published it as an open source library so everyone can use. And so this is about databases. And next we have binary formats. So binary formats are formats that are being developed internally by vendors, and all the code that's handling these files is also written by the vendors. That means that there's a lot of place for mistakes if they weren't aware of security issues. And last of all, there are text files, and those are the easiest to read, but not very fun to research because they're not complex. So those are the most common files that we find inside are the zip file, which is usually the ICS project file. And so if we'll summarize all that we've just said about ICS projects, ICS files, project files, sorry, and they are developed internally in binary formats that are pretty complex because they hold a lot of complex information, and all of the formats is developed internally, and the information and data types are also developed internally. And those traits might remind you of something, especially if you're a researcher in the ICS domain. It reminds ICS protocols a lot because they're all using binary formats, also complex, and they also hold proprietary information. And so we thought to ourselves in the research team, are ICS project files as vulnerable as ICS protocols? Because ICS protocols are known to be very vulnerable. And if you'll just look at the ICS CERT website, you'll find that there are a lot of vulnerabilities being published in the past few years involving project files. Here you can see an SQL injection and the use after free vulnerability and a Stack Overflow vulnerability. There's a lot of different kinds of vulnerabilities. And also the middle one, for example, has a high score of 7.8. So there's a lot of high scores for those vulnerabilities too. And to exploit these vulnerabilities, an attacker will need to craft, as you see here, a malicious project file and get some engineer to load it to his engineering software. And we'll show an example of it later, but that's how the vulnerabilities can be used to attack. And so it's not only that there are many vulnerabilities that are being found lately, it's also that people are starting to be more aware of those risks and care more about them. As an example, in 2016, there was published a CVE that says crashing the engineering software with a malicious project. That means if someone will double click the malicious project, the engineering software will immediately crash. And it got a CVSS score of 4.2, which is a low score. And there was a disclaimer that says, these vulnerabilities are not exploitable remotely and cannot be exploited without user interaction. Meaning the person who wrote this thought those vulnerabilities are not interesting, and therefore he gave it a low score too. But only 3 years later, in 2019, a similar vulnerability was published, pretty much the same consequences, probably a different product, and this time it got a CVSS score of 7.8. So just 3 years later, people are a lot more aware and scared of those kind of vulnerabilities. And even if those vulnerabilities need some kind of phishing attempt to work, they need to make someone press something for it, not like protocol vulnerabilities, which can be exploited more easily. Still, people are very scared of those. Another nice example is the Pwn2Own competition. Pwn2Own is a famous competition that invites hackers to find specific vulnerabilities for specific devices, and they offer big prizes. And in the beginning of this year, there was the first Pwn2Own competition that targeted ICS devices specifically, which I think is pretty cool. And there were 5 categories, and one of those categories you can see here, it was try and find a vulnerability on engineering software, specifically Rockwell Automation Studio, involving the project file loading. So that's exactly the kind of vulnerabilities that we're talking about, and shows us that an organization which is very up to date with understanding the security world is very interested in that kind of vulnerabilities. And there was actually a winner, and someone found a vulnerability and collected a $20,000 prize. And kudos for Rockwell for taking a part in the first OT Pwn2Own. That shows that they take cybersecurity very seriously. So that's cool. So those are examples that shows us that people really care about those vulnerabilities. So where are we right now? We said, hopefully I convinced you that project files are great for asset management, and they are great for researchers' employment, because if they weren't complex, I wouldn't have a job probably. And project files are great as an attack vector, sadly, because they can be used in various phishing attempts and such. And we'll show, hopefully I convince you that it's not just theoretical threats. Let's first cover some security issues that can be exploited by attackers, and then understand how can they be exploited. So I'll just take a sip of water. So just as a reminder, that's how we said that the common project file looks like, usually a zip file with many files in it, maybe OLE, databases, binary formats, and text files. So we'll go through each of those components and we'll figure out if those components are secure or not. We'll put it here so you can we can have a reference. So the first security threat that we'll cover is the zip slip vulnerability. It's a very famous one, and in a more technical explanation, here you can see the zip header, and you can see that it's not entirely textual, but the dots means something that's unreadable. But there is some text like this path here, example/file with a long name.sql or example/file1.txt. So those paths tells the extracting program to where to put the files. Those paths tell them put file1.txt in the subdirectory example. Now, why is this interesting? Because using those paths, an attacker can use the special characters for directory traversal, which are this .. to tell the parsing software to go up one directory. And this can cause the handling software to write the file to the wrong location. And in this example, we're showing that you can trick the program into writing the destroyer virus, for example, into the startup folder by going up to the root folder and then to the startup. And so if you'll do this, every time the computer will boot, the destroyer will run. So that's very dangerous. And the zip slip vulnerability is actually very well known. And it has been handled in many products, but in the ICS domain, we can still find many infected products. And just those are just examples from the past year, I think. And so let's go on to the next type of file, the OLE file. So the OLE files are being used by Office products, as we said, and it is very known that Office products are very vulnerable, like doc files, for example. And many of the vulnerabilities are found in the handling of the OLE files. So it's they're not safe, and the handling of the OLE files is usually not very safe. And just according to the FBI's recent reports, Office vulnerabilities are still the most common vulnerabilities used worldwide. So that's pretty bad. And next we have databases. So when a researcher thinks about databases, and specifically SQL databases, they think about SQL injections, which are pretty much the most famous vulnerability in the world. And it's a vulnerability in the handling of the SQL queries, and that can lead to code execution and malicious programs running. And just as an example, in the Pwn2Own competition, Amir and Sharon from my team found an SQL injection vulnerability last year, and they created a project file with a fake version number, and that led the engineering software to run SQL migration scripts that weren't safely secured. I won't get deep into it, but you can read in this blog post in ZDI the technical details. It was published as a CV and got a score of 7.7, which is high, and I actually have a demo of it. Here you'll see someone's double clicking on a malicious project file. He doesn't know it's malicious, obviously. And it opens the engineering software, as you'd expect. But also, as you see, a notepad pops up. Now, we wouldn't expect a notepad to pop up. And instead of using a notepad in this demo, we could have used any other malicious program. The idea is that using the vulnerability, they can just run any program that they want that would run in the background, and the engineer wouldn't even know. So they can infect the computer just by making the engineer double click the project file. So you see where that leads us. That leads us to obviously phishing, and we'll get into it in a few slides. But first we have two more data types, file types to go over. So the first one is binary formats, and the vulnerabilities on binary formats are very common and published all the time. And the reason for that is this: just like with ICS protocols, there's a lot of code involving handling those files, and the code is old, unmaintained, and written internally by people that weren't aware of the security risks that there are, like we are aware today. So the code was probably never reviewed for security issues at all. And here are just some examples of recent years. There's a lot of different publications on it. And actually, Edward Kovacs from Security Week wrote a nice article this last year about vulnerabilities in the Red Line Crimson software, and actually there are vulnerabilities in the compressed project files that we saw in the beginning, so they are vulnerable to some attacks as well. So that's really cool. And last of all, there's text files. So you might think that text files are very secure because what can possibly go wrong, but still, even those text files look very innocent. In the parsing process of them, usually there's a lot of low-level code involved, and issues are quite common. Just this year, Uri from my team found a remote code execution vulnerability in the parsing of a purely textual file with an I score of 7.8, so those exist too. And so we've seen that vulnerabilities in ICS project files are quite common, but do they impose a real threat or not? Because you can just ask me back, why would I run a project file that I don't know anything about it? So as I just said, to utilize any of these vulnerabilities that we discussed, an attacker will need to convince an engineer to open his malicious project file on the engineering station, on the computer with engineering software. And so when someone tries and sends you a doc file and you don't know this guy, you're probably aware of the security risks behind opening a doc file, and you probably be careful and think twice before opening it. But when an engineer gets an ACD file or any other project file in that manner, you'll probably first of all be curious to know what's in the file, what project does it contain, and you wouldn't necessarily think of the security risks of opening that file because you might not know that project files are dangerous as well. And phishing attempts, they are not rare at all. They happen all the time, and especially during the COVID-19 era. And those are just two examples of articles covering cybersecurity's phishing in general during the COVID-19 and phishing in the energy, oil, gas industry. So those attacks happen because they're pretty easy to run. And it's not only targeted attacks. An example that we found is that if you look in the online support forums, which are very commonly used, you'll find that many people are posting their questions about their project files. For example, hello, I need help with my ACD file. I need someone to load it in the software to get me the PDF. So an engineer might think, oh, I'll help this guy. And if you look into this comment section, you'll find a lot of people are helping him to load the file and to output some kind of PDF. And they don't consider for a second that that might be an attacker that's asking for help in the forum and just acting, all help me. And they're just happy to help. So they don't know that it's a big risk to open this file. And on top of that, the risk is higher, in my opinion, compared to doc files phishing, because when doc file phishing happens, someone gets a mail with an infected doc file, they might just open it on their phone or on their personal computer and nothing would happen, no damage will happen to the critical network. But when someone sends a project file to an engineer, the only way that the engineer can open this file is in the engineering station because it's the only place where there's an engineering software installed usually. So therefore, if the phishing attempt succeeds, it will run the malicious code inside the critical network, infecting it. So it's a lot more dangerous because it's a lot easier to get inside the internal network with such vulnerabilities. So the key takeaways from this talk is project files are very useful to gain visibility into your network and to understand what assets you have there, what are their versions, their models, their firmwares, and they're a great tool in general. So don't stop using them just because they're dangerous. But we have to be aware that they are indeed dangerous, just even more than doc files. And engineers must be aware not to open files that they got from unknown sources, from the internet, from random mails, because that's very, very dangerous. And we can just forget that it's dangerous and not think about it and just open the file, and we wouldn't even know that we infected the site. And project files for an attacker, they are very useful to use as part of a targeted phishing attack on ICS critical networks. Just gets you right inside the critical network very fast. And we suspect to see many more security issues coming in the following few years, and because everywhere we look, we see mishandling of data in project files decoding, and that kind of vulnerabilities can assist attackers in the ICS domain very much. So we have to be aware of them. Thank you. That's it. And I don't think we've got much time for questions, right? I can't hear you if you're talking, Liz.
Thank you. So glad. Technology is not my friend this morning. But yeah, we have a couple of minutes. If anyone has any questions, I want to pop those into the chat or raise their hand. But
you can also send any question to my email. I think it was in the slide. It's ray.h@clarity.com. So if you have any following question in the following few days, I'm happy to help.
Excellent, thank you. And recorded versions of the talks will be available on the ICS Village YouTube channel. You'll be able to find links there. So thank you. Great presentation, and look forward to seeing what else you can find hopefully next year.
Hopefully nothing.
Well. Right.
Yeah, thank you.
Thank you. And we're going to transition over
Goodbye.
to, let's see.